Hello, YouTube. This is Umozo3. So I intend for this to be the last lesson in the Python programming curriculum, right? I've had about 55 lessons where I've taught you pretty much everything I know about Java programming, right? And that's hours and hours and hours and hours and hours and hours of content. So hopefully you've got something interesting or informative or useful or curious out of these videos. But what we're going to do, we've already been talking about sorting and searching algorithms a lot here at the end of the curriculum, right? And we talked about bubble sort and insertion sort and selection sort, which are basically three different approaches that you can take to sorting a collection of sortable elements, right? Whether it's a list of integers or strings or floats or person objects or point objects or toothpaste objects, right? You can sort anything you want as long as you specify a less than magic method, right? So there are three sorting algorithms. And then we also talked about two searching algorithms, right? So we talked about the linear search algorithm, which will basically step through the tuple or list one element at a time, starting at index position 0 and going all the way until the end of the list or tuple, until a success is found, right? Until the target element is found. And we said, well, if we have a sorted list or tuple, then it's probably better to use binary search, where we're essentially reevaluating the left and right endpoints every single time. And we're almost dividing the size of the list or tuple that we have to parse through by 2 every single time, right? And you can think about how that would be a quicker procedure for basically a list of words in a dictionary, right? Where it would be a lot easier to just flip to the letter W, right? And just evaluate a couple times, is W to the left or to the right of where I'm at right now, rather than trying to go Arthur, aardvark, apple afterwards. So hopefully that's clear to you. But we implemented the linear and binary search algorithms, and hopefully that's clear to you. And the only trade-off, the only reason you would use a linear search other than a binary search is if you are working with a small list or tuple of unsorted elements, right? That's really the only circumstance where a linear search will be better. But in general, we said a binary search is going to be more efficient. And then what we do is we talked about stacks. So what we do is, remember, we have this person class. We've talked about this for multiple lessons now, but we have this person class that we went ahead and made, right? We have a constructor which assigns values to the name and age strongly private instance variables. But then we have setter methods and properties for both the name and the age instance variables, just in case we want to return or change the values of those strongly private instance variables. And then we have a string representation of an instance, and then a less than and greater than dunder, and then a length of a person. We said that the length of an instance would be the integer division of the age of that instance divided by the length of the name of the instance, right? And then also the get item dunder allows us to treat an instance of a class as though it were a dictionary that we could get values out of by passing keys into it, right? Same thing with set item. So what we're going to do is we can review stacks just briefly, right? So we created seven instances of the person class, right? So we just pass in a name and an age, right? And we went ahead and put those into a list, right? And then we went ahead and used insertion sort to sort the list. And then we said, well, we can do binary search to find a person with a particular name. So that's what we did in the previous video. And then what we can do is basically, so the goal with stacks is to create a class that can represent or implement a stack, right? And when we were talking about stacks in the previous video, we said that we need to be able to support two operations. We need to be able to support a push operation, which adds an element onto the top of the stack, and then a pop operation, which removes the uppermost element from the top of the stack and returns it. Okay, there's also sort of a third operation that we've talked about, and that's peek. And so that just returns the top of the stack without removing it. And so basically what we did is we created a pretty simple class. It's really not too difficult here, hopefully, but hopefully you understand that this is how you would implement a stack, right? And a stack is a defined data structure. It appears in multiple different programming languages. And now we can figure out how to write the lines of Python code that would literally implement or activate a stack, would get an object to work the exact same way that someone would think of a stack as working. Okay, so this is a constructor, and the constructor would create an empty list for items. Okay, so items is an instance variable. It's a list that's initialized to empty when the object is first created. So hopefully that's clear to you. But you would say is empty. So do you want to see if a stack is empty? You would see whether or not the length of that list, so the length of the list is 0, right? And if it is, then we would say that the stack is empty. And we can push an element onto the stack by saying self.item. So that refers to the list that the instance is being represented by. It's a list that the stack represents, right? And you would say that for that list, we want to insert at index position 0, we want to insert an item. And we talked way back in lessons 8 and 9 and 10 about if we call list.insert of, and then we have two inputs. The first input would be an index position to insert a new element at, and the second parameter will be the new element to insert there, right? And all subsequent elements will be shifted one position to the right. But that's how you push an element onto a stack, right? And then if you want to pop an element off of a stack, which amounts to returning and removing the top of the stack, basically that would return the uppermost element, but then it would no longer be the uppermost element because you're removing it. And so you would say to remove equals self.items of 0. So you would get the element at index position 0, and you would go ahead and remove it. So you would remove that element that you identified. And then you would go ahead and just return that element that you just removed, right? And then it would no longer be the top of the stack. It was the old top that is now stepping down from the throne. And then if you have peak of self, right? So if you have the peak method, that would just return self.items of 0. So that would just give you the top plate. It would give you the top element on top of the stack, but without taking it off of the stack, right? And then if you wanted to print the stack, you could just say for each of the elements in that list, right? In self.items, you could just say print of element. Okay, so it would just print a representation of the stack. And we tried that out. So we said my stack equals stack. So you just create a new instance of the stack class. And then we basically created a new instance of the person class. And we said, well, we were going to push the person onto the stack. And that's totally legitimate. But you could also push a Boolean onto the stack, or a string onto the stack, or a float onto the stack. Okay, so now what we could do is we run main.py, and let's figure out what we would get here. So now if we go ahead and run this code, we would get, well, what we would do is we could go ahead and pop these values off. So what we could do is we popped off the 3.52, and then we popped off the new top, which was hot dogs. And then we popped off the new top, which was false, right? Because we're removing these tops, and then suddenly false was at the top. But then when we yield that again, now that's removed. So now our stack only has one element in it, right? What if you had made all of these peaks, right? So what if you had just looked at the top element each time without removing it? Well, then you would have gotten 3.52 over and over again, and then you would get 4 for the length of the stack, and then you could go ahead and iterate through the stack and print each of the elements in it, right? And then all 4 elements would still be there. But that demonstrates the push and the pop operations, right? And also how peak works. So hopefully that's clear to you. What we're going to do in this video is we're going to talk about another type of data structure, right? So we've already talked about lists, tuples, sets, dictionaries, and now stacks, okay? What we're going to do is we're going to talk about queues, okay? And so in order to understand queues, what I think it would be helpful to do is to go ahead and try to pull up a Wikipedia article, and you could think about a queue, right? And it's not that hard to find. So usually we would be talking about an abstract data type, right? And so what it says is in computer science, a queue is a collection of entities that are maintained in a sequence and can be modified by the addition of entities at one end of the sequence and the removal of entities from the other end of the sequence. So what I think it would be helpful to think about is people at a supermarket, okay? You go to Walmart or something like that, and there are people that line up in a line when they're waiting to pay for their groceries, right? And the first people who come into the line are the first people who are going to get served. So this is a data structure called first in, first out. And that makes it completely different from stacks, which is what we talked about in the previous video, because with stacks, we had last in, first out, right? If you put a plate into the stack, if you're the very first plate that goes onto the stack, it's going to take a long time for that plate to come back out of the stack. Well, with the queue, it's the opposite. If you put a person into the queue, they're going to come out more quickly, right? You know, so they would just be the first element added to the queue will be the first one that's removed, right? And so with the plate example, right, you can think about sort of a stack of plates on its side, right? But with the stack example, if you're, you know, putting things into the stack, you'd be taking them out of the same side. But here you would be removing elements from the opposite side, okay? And so it says it provides services in computer science and operations research. This is a pretty helpful thing in engineering and computer science and industry. Like, there are a lot of companies that talk about stacks and queues, but what we're going to do is we're going to create a class in Python that will basically embody it, will implement this queue, and we're going to figure out how a queue operates and what are the legitimate operations on it. So hopefully that's clear to you. But what we're going to do is we can go ahead and look at a class called queue, okay? And we can go ahead and compare and contrast with a class called stack. With the stack class, we had an init constructor, we had something to see whether or not the stack was empty. We could push and pop elements from the stack, right? Basically add and remove. And we could just peek at the top of the stack, just look at what's at the top of the stack without removing it, and then go ahead and print the stack. Okay, so presumably we're going to want equivalent operations for a queue. We'd like to be able to create a queue, see whether or not the queue is empty. We would want to add or remove elements from the queue. We would want to go ahead and look at the first person in the queue, right, the front of the queue, without removing them from the queue. And then what we could do is we could go ahead and look at print stat. We could go ahead and look at the at print queue as well. Okay, and so that's what we would be looking at here. And so what we have to do is a little bit of comparing and contrasting, because when we were looking at a stack, we started out with an empty list, and every time we added or removed an element, it was basically at index position 0, right? Like hopefully you can see when we said push of self comma item, we said self.items.insert of 0 comma item, right? So it's inserting and removing elements from the beginning, right, from index position 0. But with queues, if we're going to have an index position 0 representing the front of the queue, then the back of the queue is going to be the opposite, right? It would be the length of the queue minus 1. It would be the length of the list minus 1 will be the last valid index position within the queue. But anyway, let's talk about that. So we have a constructor for the queue, and we're going to say self.items is equal to the empty list. Okay, so it creates an instance of the class, an instance of the queue, right? And then here, I think I just copied and pasted, but this would be to create a particular instance of the queue class, right? And then we would check to see whether or not the queue is empty, and we would just return length of self.items is equal to 0, right? So we would return true if and only if there are no elements in the queue, right? So when you copy and paste things, you just have to be a little careful and make sure that you're making the proper adjustments, okay? But you would just, you know, return true if the length of the list representing the queue is 0, right? And obviously, why would you want to represent a stack or a queue with a list or tuple? Well, because presumably stacks and queues are going to change, right? We're going to be adding and removing elements from them. And like we've said for about 30 or 35 lessons, tuples are not modifiable, right? You can't add and remove elements from a tuple. So it would not make a lot of sense to represent items with a tuple, but you could represent it with a list, okay? And this is an example of a queue where you could have duplicate elements. What if you wanted to implement a queue that could not have duplicate elements? Well, then you'd be talking about a set. But the problem with doing that is that a set does not have index positions, right? A set doesn't have index positions. So what you'd end up having to do is do like a try-catch block, right? You could only go ahead and add an element if it didn't already exist. But anyway, what we're going to do is see whether or not the queue is empty, and then that would be whether or not length of self.items equals 0, right? And then we could also say push of self comma item to go ahead and push an item onto the queue. So we would add an element to the front of the queue. Okay, so what we would do is we would say return. So we would say self.items.insert of 0 comma item, right? And so basically what this would do is it would insert an element at index position 0 and shift all subsequent elements one index position to the right. Okay, it's the exact same thing as we talked about with lists, right? Remember way back in lessons 8 and 9, list.insert of A comma B inserts that, you know, inserts at index position A element B. Okay, so hopefully that makes sense. And then define pop of self. So now we have to be careful, because now with the stack, we would have been removing the element at index position 0, right? The element that we just inserted, we're going to be removing. But with pop, we want to actually remove the element from the end of the queue, right? So we would be talking about removing an element from the other side of the queue. Okay, so we would basically be saying the last element in the list that represents the queue. Okay, and so that would be basically the last element from the queue which is being removed, right? And so what you would do is you would figure out the item to remove, and so you'd say to remove equals self.items of, and you'd figure out the index position corresponding to the end of the list, and that would be the length of the list minus 1, right? We talked about how that's always the last valid index position of a list, right? And then you would say new items is equal to an empty list. And basically what we're going to do is we're going to reassign the items instance variable. So the list that represents our queue, we want it to be basically the original list. But what we're going to do is we're going to chop off the last element, right? So we're going to take everything except the last element of items, right? Dot, 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 and retain, you know, all elements except that last one in the items instance variable. So in our new items instance variable, it's going to be the same list as it was, but with that last item chopped off, with that last element removed, right? Because we're popping it off, we're removing the first person who came into the list, we want to get rid of them, right? So we would say return the item to remove, right? So that would go ahead and remove the element from the right side, from the end of the queue, okay? But whenever we add people on, they're going to basically come onto the beginning, right? So you're going to remove people from the right side of the queue, but you're going to add people onto the left side. That's how a supermarket works. And that's basically what a queue is, right? And then you could also say peak of self. And so that would just return items of length of self.items minus 1. So this would just return basically the rightmost element in the queue. So it would return the rightmost elements in the queue. You have to think about items coming into the queue from the left-hand side, like into index position 0, and then out the back, right, out the rightmost side of it. But this would just be looking at the rightmost index position without removing it. That's what peek does for both stacks and queues. It just looks at it without removing it. And then we could have defined print queue of self, right? And we could say for element in self.items, right? For each of the elements in the list that represents this queue, go ahead and print the element. Okay, so hopefully that makes sense to you. But what we could do is we could try this out. And so we would just have to create a queue, and then we could add things onto the queue. And I think what I'm going to want to do is delete the stack example just so that that's not confusing and we don't have too many things printed on the console output at the same time. But what we could do is we could say sample queue equals queue, right? And you would just call the default constructor. You just call in the constructor that doesn't accept any parameters, right? This is an empty constructor. But now you can go ahead and add, you can push items onto it. So now what you could do is you could say sample queue dot push of 10, right? And then you could say sample queue dot push of 22, and then sample queue dot push what if we say E greater than F, right? And so that would be a Boolean expression, right? Does E appear after F in the dictionary? And the answer is no. So this would be a false Boolean that we're pushing onto the queue, right? And then we can do one more. So what if we say sup? Okay, and then what we could do is we could go ahead and try out some of these operations, right? So we're already testing out the push operation, but hopefully this would no longer be empty, right? So we could say sample queue dot is empty, and hopefully that would print false on the console, right? So hopefully that makes sense to you. But if we had gone ahead and cut and paste that line to before the time that we push or add elements onto the queue, then it returns true. Okay, so by default our queue is empty, right? And that's true for our implementation, but that's also true for queues in general. Presumably when you create a queue, it's going to start out as having no elements in it, right? You wouldn't have anything to start out with until you start pushing elements onto it, until people start showing up in the supermarket line, right? And then you can look at pop and peek and print queue, right? So what if you say print of sample queue dot peek, right? So what if you go ahead and look at, what's basically what made it into the queue first? So that was 10, right? And then you could print that multiple times, right? So you could go ahead and keep peeking at the element that made it into the queue first, and it would just give you 10, 10, 10 again, right? But then if you go ahead and change these to pops, hopefully you can see that there's something different that would happen here, because now what we're going to be doing is removing elements, right? So now we would remove 10 from the queue, and then remove 22 from the queue, and then remove false from the queue. Okay, so now what we could do is we could say let's print the queue, and then what we could do is we could say sample queue dot print queue. We could call the print queue method that we made, which is instructed to basically just print each of the elements in the list that represents that particular queue instance. So now what we could do is run main.py, and you can see there's only one element left in the queue as a result of calling pop over and over again. So this basically removes the rightmost element from the queue while returning it. Okay, and then it basically is no longer in the queue, right? And then you can mix and match these commands and just make sure that you're comfortable with these different commands, right? So what if you called pop and then peek? So then we would be removing the 10, but then we would call peek on the 22. So we would actually get two 22s, right? This would show 22, but it would not be removed, but this is 22, and it would be removed, right? So now if you go ahead and run this code, now you get two 22s. So that's the distinction to be made between stacks and queues, is that stacks is a last in, first out data structure, or if something comes into the stack earlier, you know, it won't be removed until later. And then a queue is the opposite. So a queue is first in, first out. You know, the first things that come into the queue are going to be the first things that come out of the queue. So that's data structures, advanced data structures, and the extent of what I can teach you about Python. So from UMills03, thanks for watching all of these wonderful videos, and please subscribe.